Hi everyone, I hope you're well. So I'm glad to show you a progress about TypR, so a typed version of R, and I will show you what I've got until now. First of all, I have to thanks every person that helped in this project by just suggesting the idea, telling their point of view, or just showing their experience, because with that I was able to modify TypR in a way that I think serves most people. Yeah, I didn't take all the ideas because some of them are not implemented, or other will be literally contradictory to the aim of the project, so that's why. But I think one point where everyone could agree is about gradual typing. So in short, gradual typing is a way of putting type just progressively. You don't need to have type everywhere in a project. It's just that you can bring them yeah, step by step without any pressure to make everything typed. So let's see that together. Let's start with the beginning. So as I say, it's gradual typing. As I say, TypR works with gradual typing, but you can also notice that it's still statically typed. We have one rule, it's the semicolon rule. You need to put semicolon in each statement, in each variable declaration, in each expression, because that's how it works, and I need that to have a clear structure to be able to build more complex and interesting features in TypR. So TypR bring also other features that need a semicolon, so I can distinguish which part of the code we are using. Let's build a variable. I just put a variable that's named 7, and I just can display its value by just running, and we see that we have a result. We have a type checking, it's an integer with the execution of 7. So until now, nothing new. We can also change the value. For instance, this time I will put a 3 there. This time I change the value, it's a 3. So yeah, that's, I think, yeah, we have to change first of all, because I put some elements mandatory, but this time we don't have them. For instance, I wanted to bring immutability, but I think it's up to the developer or to the scripter to choose what they want to use. So let's just see something else. This time I will use a boolean. Let's see what we get. And this is what we are getting, a type error. So it just say that we can't change the actual type of the element. So I can change the value if it's still within the scope of the types we designed. So that's one rule we can have with TypR. If I want to redesign and repurpose a variable, I can just use the let keyword. The let keyword helps me repurpose the goal of a variable, and I can change the type quite easily. Also, I love using the let symbol because it helps me see where I declare a variable. So I am always aware of where I'm building or constructing a variable. Another another component that can be interesting is the way that we can use simple R code. As I say, we don't need to build something that complicated. Another thing new is that we can also build ourselves some kind of function. For instance, we'll just create a new function. I will name it addition. So that's a classic R function, but as always, we need to put the semicolon. And as you see, the operation is working quite well. But I think you noticed something. The expression of the function don't have a type. So when we are not typing a function or an element or something like that, for instance, a function, we won't get a result type. It will just return an empty type. Even when I put it in a specific variable, you know, we see that variable don't have a specific type. It's just the type empty. One powerful move we have is just to specify target type. So since the type returned is an empty type, we can just put any target type and TypR will take it as it is. So yeah, we have to be cautious about what kind of type you specifying. And so now res has the type int and follow the classic and general rules. You have also the power to use existing R function. So for instance, we have a print function. So I didn't have to type it and to see what I can get. So like that, it returns the empty type, but I can still execute it since it's also classic and basic R code. I can also use function from other packages. Like for instance, I'm using string R and I am just using the function that belongs to these packages. So as you can see, you can also work with existing R projects quite easily. We also have this kind of notation, so that's a syntax trigger that helps us to apply a function with the first parameter in the same element. So that's the same as using this operator. That's the same. But what happens if you still want to have those functions, those already existing functions typed? So you can still use that with a specific notation that I call signature. So you can define a signature for existing function. Also functions that are not in base R, but for instance, I'm using it in the strLength function and it's still working. Now we can see it returns an integer because I specified it. So once again, you need to be cautious because that's, yes, it's up to you. It's up to you to define the type. So if you get it wrong, it can be problematic, you know. One thing that's not there yet, but I need to do in the future, is to help building function who have a specific. What I also need to put in the future is a way to define function that can has an infinite amount of elements. For instance, a data frame and the concatenator of vector, because I can take really an arbitrary amount of elements. So to work with them, we can type them quite directly. I think you noticed that data frame don't have a dot operation, because since I have used the dot operation for other kind of construction, so if you want to point some kind of function element or variable that has a dot in their name, you need to put a double underscore. What if I need to have a specific types from package that, for instance, define its own kind of type? So I can just use a specific notation with a signature notation. I just put a name without a definition of its type, and it becomes its own type, some kind of opaque types. So this way I can also use it there, data frame, and now it's accepted. TypR recognizes it as a specific type on its own. Now I can import a library, for instance dplyr, define a specific type, some kind of data frame, and I can define the signature of a filter function that helps us to filter a data frame according to some elements, and it take a data frame, use an any, and return a data frame. So like that I can use data frame filter and just put some kind of meta programmation. So that's why I use this kind of block. So that's a specific block that will be taken as it is. So that's just a way to cheat my way out. So that's why I put an any. But I think I can do better in this case and find a cool way to type it. As you can see, the type checking is working. So now we have a data frame. But you will see that in the execution we have some error, because yes, I like the way the tidy team has made their tools, because there is also some kind of type check about how it's working, and they put a stack trace that helps us know where it is. To mitigate this problem, we can define something interesting, because I made a new type of classes. So that's the R classes. To mitigate this problem, I have made a new kind of type. So it's named R classes, and I will just show you how it's working. So the classes type are a new way to bridge R type with TypR type in this case. On recommence. So R classes are a way to bridge TypR classes and R classes all together. So I just doing a mapping that data frame are just targeting this kind of classes. And if I run it, now we have something good, because TypR know it's a kind of data frame, and it's type checked, but also R is still working the way we expected it to work. So yeah, that's a new way you can bring your knowledge about R and add it up with a type system of TypR. So that's a way to put some kind of connection. But there is also other kind of type that can be really interesting to work with in TypR that I didn't show, but perhaps we show one of them because I think that's also one you're using. For instance, lists are already typed in this case. For instance, I have a list with the name Lisa on age 25, so it identifies it as a list. So with fields age and name of type int and char respectively, and it will give a list according to what we know. So to create typed version of a function, you just have to put the name fn instead of function. So now TypR we know that you're talking about a typed function, and you can just put your parameters with their type definition and the return type to be sure as the type is correct. And you know you can use it. So I put a type. So I put a signature because I forgot to put it into the main library. So don't worry about it. So the execution is working. Ah non, c'est déjà là. Of course, there is also option types. We also have union types, for instance, that will help you have an arbitrary number of type function can take or return. Of course, you can still build your own type annotation to be able to use it simply. You can also use pattern matching, so you can decide what to do about the type you're receiving. And there is a lot more things on elements I am working on in this language, so I want to bring some kind of cool functionality. And there is a lot more in these languages. There are also other cool functionalities. I didn't talk into the detail because I think you've seen some strange elements in them, but you can also learn them with your own pace, because now I have created documentation I will start filling progressively. So we have documentation on how to get started, on the main documentation about how to use TypR. And the main documentation about how to use TypR. Interesting. Also, if you want to contribute in this project, you can, for instance, and if you want to contribute to this project, you can, for instance, work on the code base, suggest your ID. And I also have a Patreon, so if you want also to give me a little something, for instance, buy me a coffee. I also have a Patreon, so if you want to, also to give a little something away, you can also do that. Also, I have a Patreon, so if you want to contribute in this way, also you can do. I also have a Patreon for those who want to contribute financially into this project. So this is what I have for now. So I think I will still work on this project to be sure that everything is stabilized, and I will bring step by step all the kind of elements we need. But I think it was a real need to start the project from something that everyone can grasp and go further little by little. So that's why the goal of this project is now to make it seamless to work with TypR or with R in general. And after that, show some kind of powerful functionality one can get, for instance, by using TypeScript. So I have a lot of cool ideas also I will implement in this language, and I hope people will like that. So actually we can't really change the core language. So actually we can't change the core R language. So I can bring directly the type, but I think perhaps one day the core team will be inclined to bring some kind of type into the R system. So yeah, this project is fun, and I hope it will help in the future. So I just have to say all the best and see you soon. All the best and see you soon.